Once you have given these problems a try on your own for factoring, you can go ahead and continue the video for the solution for these four parts when we're factoring and finding x-intercepts for polynomial that are with coefficients not equal to 1. So to get started, I'm going to again write out what the product needs to be and what the sum needs to be again. So the product using the AC method for leading coefficient not equal to 1. We get 3 times 4 are the products of A and C, which is 12. And for sum, we want it to be equal to B, which is equal to 13. And in this case, we can think about the two numbers that would have a positive product and positive sum, meaning the two numbers must both be positive. And listing out the factor pairs of 12, hopefully you get a chance to try that, but if not, take a minute to write out the factor pairs of 12 first. And in this case, the two numbers that would work out would be the numbers 1 and 12, and no other numbers should work out to have the results we desire. And with this, we can rewrite f of x to be equal to 3x squared plus 1x, that 1 can be omitted, plus 12x, then lastly plus 4. We keep the first and last term and rewrite the middle term to be a sum of two terms using the two numbers we found as coefficients. And once we get that, the first group go together, second group go together, connected by addition. Within the first group, the GCF is going to be just a variable x. And if we factor that out, we're left with 3x plus 1 over here. Within the second group, remember we are factoring a positive number, so I'm just going to keep the plus sign. We have 12x and 4, so they share a factor of 4, which gives me again 3x plus 1. That's going to be the common expression they share. So we have 3x plus 1 factored out. From the first group, I'm left with x. From the second group, I'm left with positive 4. Now if I want to find the x-intercepts, I want to set each expression in the parentheses equal to 0. So 3x plus 1 is equal to 0, or x plus 4 is equal to 0. Meaning 3x equals negative 1, x equals to negative 1/3, or x is equal to negative 4. And then we can list out the x-intercepts as negative 1/3, comma 0, and negative 4, comma 0 as a result. And now moving on to part B, we can do the same thing as before. We can see the product is going to be the product of A times C, which would be 2 times negative 10, or negative 20. I'm running out of space a little bit. And the sum needs to be equal to just B. In this case, the coefficient B is equal to negative 1. And when the product is negative, that means the two numbers must have opposite signs. And let's forget about the negative sign a little bit and think about the factor pairs of 20 first. They can be 1, 20, 2, 10, 4, 5. These are the factor pairs we can have if we're just concerned about 20 as a product. And now, as we said, the product is negative. Also, the sum is negative. That means a negative value must have a larger absolute value. So that tells me my negative sign needs to go on the number with larger absolute values. So that could be negative 20, negative 10, negative 5 from each pair. And now if we go ahead and add numbers up in each pair, we should find the numbers we want are 4 and negative 5. That would give me a sum of negative 1. With this, I can start rewriting g of x to be 2x squared minus x really becomes plus 4x because we have positive 4x, and a negative 5x, and then lastly minus 10. And grouping them together again, connect them by addition. The first group would leave me with a GCF of 2x. And once I take that out, I have x from the first term and 2 from the second term. Now for the second parentheses, we see the leading term is negative, so I'm going to factor out a negative number or negative value. So plus a negative value becomes minus, and the GCF is a -5, so I keep the 5, and that leaves me with x plus 2. Again, remember to change the sign of every term inside the parentheses once we factor out a negative GCF. Once we get that, x plus 2 is what's shared between the two groups, leaving me with 2x from the first group, -5 from the second group. Using zero product principle again, if I want g of x equal to 0, that tells me x plus 2 equals 0, or 2x minus 5 equals 0. And x is equal to -2, or 2x equals 5, x equals 5 halves as a result. And therefore our x-intercepts are -2, 0, and 5 halves, 0 in this case. And that's going to be the solution for the first two. And if you're good and ready to move on to part C and D, just continue on with the video. If you need a little bit more help, take some time to work on C and D on your own first and see whether you can get further if you didn't go all the way through before. Now moving on to part C, we can go through the same process. The product is going to be 8 times -9, 8 times C, which is -72 over here. And again, when I'm doing these calculations, I'm always checking that I don't have any GCF to take out at the first place. So 8, 6, and -9 don't share anything, so I can't do much. Now for the sum, we have the linear coefficient b equal to 6. So that's what my goals are, to find the product being -72 and the sum being +6. Let's think about 72 for a second as to what are the factor pairs that would work out. And at the beginning it might take you a little longer to write out the list of factor pairs, but this is kind of a way to guarantee that you don't miss anything along the process. 72 has a lot of factors as is. I believe I have listed all the possible factor pairs in this case. Now I want the sum to be positive while the product is negative. That means my positive value should have a larger absolute value. So in each ordered pair, for the larger numbers, I'm going to indicate that's going to be positive. For the smaller numbers, they need to be negative in order for this to possibly happen. So the candidates are going to look like this, where I throw the negative sign in front of all the smaller numbers to start with. And now if I add up the numbers in each factor pair, they should always be positive. Going through some checking, you should see -6 and 12 is the pair that we like over here. We want the sum to be +6. So now we can write h of t to be 8t squared, and then I have -6t plus 12t and -9. Again, first two together, last two together, connected by addition. Going through this, the first group has a constant factor of 2 and a variable factor of t in common. Taking that out, I'm left with 4t from the first and -3 from the second. Looking at the second group, 12 and -9 share a factor of +3, so I'm going to leave it as +3. That leaves me again with 4t minus 3, like this. And as a result, if I factor out 4t minus 3 from each group, the first group gives me 2t left, and the second group gives me +3 left. Now using zero product principle, 4t minus 3 equals 0, or 2t plus 3 is equal to 0. So 4t equals 3, t equals 3/4, or alternatively 2t equals -3, or t equals -3/2. So for our t-intercept, we can get 3/4, 0, or -3/2, 0. Similarly, if you're ready to move on, in part D, we want to think about how we can go through this process. And part D, again, is another example where if you look at the coefficients to start with, 9, negative 15, and negative 6, they do share a common factor of 3. So k of t is really equal to 3 times. Now I'm left with 3t squared minus 5t minus 2 over here. So now I really have a new polynomial to work with, where a equals 3, b equals negative 5, and c equals negative 2. So my product here needs to be 3 times negative 2, the new a times new c, which is negative 6. And the sum needs to be equal to b, which is equal to negative 5. And now if we think about the numbers we have to work with, it's much smaller and much easier to come up with. And if you are fluent with this, you will eventually see that the numbers that we want are going to be 1 and negative 6. As is, they add up to be negative 5 and multiply to be negative 6. With this in mind, we can go ahead and rewrite the part of the expressions inside the parentheses. So I'm just going to focus on 3t squared minus 5t minus 2 for a second. This is equal to 3t squared plus t plus 1t and minus 6t, then minus 2, which we just bring down. Again, the first two go together, last two go together, connected by addition for now. And in the first group, we just have a variable t in common, leaving us with 3t plus 1. And in the second group, we see the leading term is negative, so I'm going to factor out a negative value, making plus a negative becoming negative or minus. And 6t and 2 share a factor of 2. So if I factor out negative 2 from the first term, I would have a positive 3t. Factoring out negative 2 from negative 2 gives me a positive 1 over here. Again, the change of signs. Once we get that, we would have 3t plus 1 shared by two groups, and t minus 2 left. As a result, for a zero product principle, 3t plus 1 equals 0, or t minus 2 equals 0, meaning 3t equals negative 1, t equals negative 1/3, or t equals 2. Again, listing out our t-intercepts, we get these 2 points over here as a final answer.